All right, good afternoon, good morning, good evening, good night, depending on when you're watching this video. So in this video, I want to work through the additional p-value practice problems that are given on slide 35 of lecture set 8. So the purpose of these 4 exercises is just to go over finding p-values using the student t-table. So for example, in part A, we have the alternative hypothesis is that mu is greater than 4. Our test statistic is 3.353, and our sample size is 89. All right, so what we would have here is first, we would sketch out the area that we're looking for. So we are told that this is an upper tail test because the alternative hypothesis has mu greater than 4. So we would mark down where our p-value would be located. All right. And then we would shade the region corresponding to that value. So it's an upper tail test. So the p-value is the area above the test statistic. So here we have the p-value is the probability that t is greater than 3.535. We have 89 degrees of freedom. So we go to our t-table. We are looking for 89, or sorry, we have n is equal to 89, right? So this means that the degree of freedom is n minus 1, which is 88. Okay, so we go back to our t-table. We have 88 degrees of freedom. So we're between 85 and 90. We always round down with degree of freedom. Okay, so we're going to take 85. And then our test statistic is 3.535. So as we move across this line, we're bigger than all of the values that are listed here. Right? So we are greater than 2.635. So that means that our only bound is this 0.005. And again, as we move across the tail areas, you can see that as we get bigger in the t value, we get smaller in tail area. So we would say from t table, the probability that t is greater than 3.535 is less than 0.005. Okay, so therefore the p-value is less than 0.005. Okay. All right, and then we have to decide whether to reject. So let's assume in all cases it's not stated. So anytime it's not given, we just let alpha be 0.005, reject H0 since the p-value is less than alpha. All right, part B. So the alternative is that mu is less than negative 2.46. The test statistic is negative 1.535, and n is equal to 16. All right, so here we have n minus 1, which is 15. We start by sketching out our t curve. Okay, centered at 0. Okay, so in this case, we have a lower tail test. We're being told that mu is less than negative 2.46. So we mark down our test statistic, which is negative 1.535. Right, and now what we want here is this area to the left, okay, because it's a lower tail test. So here we have the p-value is equal to the probability that t is less than negative 1.535. Okay, so the trick here is that this probability, so the lower tail probability, is equal to the upper tail probability. Okay, so the probability that t is less than negative 1.535 is the same as the probability that t is greater than 1.535. So we go to our t table, we have 15 degrees of freedom, which is here. And our test statistic is 1.535. So if we look here, we can see that this number is in between 1.341 and 1.753. So the probability that t is greater than 1.535, which is the probability that t is less than negative 1.535, is between 0.1 and 0.05. Okay, so from t table, 0.05 is less than the probability that t is greater than 1.535 is less than 0.1. Okay, so therefore 0.05 is less than the p-value is less than 0.1. Okay, and then again, we'll let alpha be 0.05. Okay, so this will be consistent. All right, and so if alpha is 0.05, our p-value is bigger than 0.05 and less than 0.1. So any number in that range that we found for the p-value is greater than 0.00, is greater than 0.05. So we do not reject since the p-value is bigger than alpha. All right. Okay, in part C, we have HA, mu is different from 1.18. The t value is negative 6.535 and n is 468. Okay, so here we start off, our degree of freedom is 467. All right. Here's our sketch of the t curve, centered at 0. Our test statistic is negative 6.535. Okay, so what we're going to do here is take the negative and we're going to consider the positive of this number because it's a two-tailed test. So regardless of the value of the test statistic, when we're running a two-tailed test, we always have to consider both tails. All right. So in this situation, the p-value is the probability that t is less than negative 6.535 plus the probability that t is greater than 6.535, which is 2 times the probability that t is greater than 6.535. Okay. So we always want to use this upper tail expression because with t-tables, the table gives us upper tail area directly. So we go back to our table. Our degree of freedom is 467. So we're between 400 and 500. We always round down. So our degree of freedom that we're going to use is 400. Our value is 6.535. So you can see that this number is bigger than any of the values listed on this line. So that means that the probability that t is greater than 6.535 is less than 0.005. Okay, so from t-table, the probability that t is greater than 6.535 is less than 0.005. Therefore, the p-value is less than 2 times 0.005. The p-value is less than 0.01. So if we let alpha equal 0.05, then we would reject H0 since the p-value is less than alpha. So anything that's less than 0.01 is less than 0.05. Okay, so in part D, it's the same problem that we had just studied in part C, except that the test statistic is given as a positive number. But this doesn't matter in terms of setup. Okay, so here we have, if we take the p-value approach, 2.349. So we have df equals n minus 1 is equal to 38. Right? So our t-value is 2.349. Okay, so we mark down 2 boundary points here. So regardless of the value of the t-value, we still have to take the same approach. Okay, so our area for the p-value is the area to the right of 2.349 and the area to the left of negative 2.349. So just like above, we have p-value is the probability that t is less than negative 2.349 plus the probability that t is greater than 2.349. So this is 2 times the probability that t is greater than 2.349. Okay, so we have 38 degrees of freedom. We go back to our t table. We have 38 here. Our test statistic is 2.349. So that is in between these two values here. Okay. So if we go up to the top, that means that we are bounded by 0.025 and 0.01. All right, so our tail area is between these two numbers here. So we would say from t-table, 0.01 is less than the probability that t is greater than 2.349 is less than 0.025. So therefore, 2 times 0.01 is less than the probability is less than the p-value is less than 2 times 0.025. So 0.02 is less than the p-value is less than 0.05. Okay, so our p-value is between 0.02 and 0.05. So if we let alpha equals 0.05, we would reject H0 since p-value is less than alpha. All right, so that's 4 more examples of finding p-values using the student t-table and then using that range to make a conclusion about whether or not to reject the null. As always, if you have any questions, please let me know.